So last week's video was a simple explanation of 3D models and animation. However, like normal, I want to share some of the problems and difficulties I encountered and just generally how I implemented it. First off, I use Blender to create my 3D models and animations. You may have heard of 3ds Max and Maya among others. However, in my game engine, I use the following axis. X is across, from left to right, negative to positive. Y is up and down, negative down, positive up. And Z is inwards and out, negative inwards, positive out. I use this particular axis because it's the default one that OpenGL uses, and it's how I've learned 3D graphics, so it's easy to visualize a problem if I'm familiar with the orientation I'm using. Blender, however, has the Y and Z axis swapped, and the Y axis is also inverted, positive inwards, negative outwards, meaning that all my models, skeletons and animations have to be converted when put into my engine. As I said in the last video, I'm using the Collada file format to store my models and animation. This file format is really good as it provides almost everything I need except for multiple animations. Now, there are a few ways I can approach this problem. Either I could make each animation its own file and load them all in to act on a model with the same skeleton, or I could put all the animations into one file with the model and use an extra text file to define the name and duration of each animation. I personally like the second option, as it would allow me in future to expand the text file to have other timestamps, such as sound effects that play along with the animation. Once we get into the code for the game engine, the model data is converted into my own model structures that prioritize the data I need. There isn't much to talk about there, as you should be able to realize, based on everything I've said so far, what I feel is important in the model data. An important point is that when the models are loaded into the game engine, they are not automatically loaded into GPU memory. During rendering, when a model is rendered for the first time, it will then be loaded to the GPU. This means that only models currently in the level will be loaded into the GPU memory. Now we need to actually program all this ourselves in order to apply the animation to the skeletons and the vertices of each model. This is some complex math, so I'll try to keep it fairly simple here and avoid much of the jargon. When rendering a screen, we first update all the animations with the amount of time passed since the last screen was drawn. Then, each bone that makes up the skeleton has its position and rotation updated in regards to the timestamp of the animation. Since each bone position is based on its parents, we work upwards through the bones, updating parent bones, then children. Then, all the bones are passed to our GPU in what's called the vertex shader. This code then runs on the GPU, changing the position of all the vertices as they're drawn to screen. Now, a bunch of graphics pipeline code is already here, and we don't need to worry about that. What's important is the skeleton code. As each vertex is read in, its position can be modified by up to 3 bones on the skeleton. We read what bones should affect that vertex, and then apply the changes based on a weighted number to determine how much the bone affects that vertex. Now, in order to actually program all this, it's obviously a very long process. Doubly so because I've only programmed this process once before, and it was in JavaScript and not C++. My approach was to do this thing in parts. First, I added some code so that each vertex was only affected by one bone, and then the code to create the bone positions. Then, the animations only sampled the positions from the closest keyframe, so in our door the only positions it would be were completely open or completely closed. From this, we interpolated between timestamps in the animation, which means that the position values were averaged from the closest 2 keyframes, based on the timestamp of the animation. Now we have a door that swings open and closed. Next, we want to have vertices that are affected by multiple bones. The door model isn't good for this, so in comes a bendy column with easy to see vertex lines. This should have been a simple change to the vertex code, however many things went wrong at this point and took hours of debugging to finally find all the problems. But at last, I had a column that bends smoothly, or as smoothly as a low poly column can bend. So far, all our animations have been running on a loop, which is good, but not everything works on a loop like that. After creating a selection interface, which is a whole other video for another time, the animations were set to run on activation, and we finally have a door that can open and close. So that's an overview of models and animation, and how they relate to my engine. This stuff is my bread and butter when it comes to programming, so you can bet I'll talk about it more later, but for now I think I've covered all the basics. Next week I think I'm finally going to get around to doing that video on collision, since as of writing this, the first collision model has just been completed. Stay tuned for a rather novel way of implementing collision detection. Thanks for watching.